Hello and good evening to the panels. My name is Sebi and my metric number is CN100184. Okay, so today I will present about my research, which is the title is a study on bamboo as an alternative material for cooling pad. Okay, next we go through the content. Okay, so here is my content for the entire slide. First, I will explain about introduction and will continue by the problem statement, objective, scope of study, literature review, methodology, bamboo cooling pad tools, and then testing and end with discussion. Okay, so now I will explain about the introduction. Okay, so the principle of direct evaporative cooling is based on the fast shift of matter from liquid to gas, a result of heat absorption from the surrounding environment, which in this case is the air cooler. So in this scenario, water absorbs heat from the hot air and also utilize its own heat to evaporate, cooling both the water and the air. So once the water reaches a constant temperature, all of the heat from the evaporations is absorbed by the incoming hot air, increasing the cooling rate of the air. Okay, so the main advantage of evaporative cooling is that it is more efficient when the temperature is higher. That's mean when more cooling is when more cooling is necessary. Okay, so for the evaporative cooling is generally more efficient where air temperature is high and relative humidity is low. And another important fact about evaporative cooling is that it consumes very small power. Only a fan is needed to drive in case of a fan pad system. So if the water circulation is necessary, then a water pump is also driven by the power, but both of them consume less power than other traditional cooling system. Okay, so air is cooled by passing through a weighted surface, which is cooling pad, and then loses a certain amount of sensible heat, so increases an equal amount of latent heat of water vapor. There are many factors which affect the efficiency of the evaporative cooling process, such as the surface area and thickness of the pad, and then the material of the cooling pad, perforation size, air flow rate, and then inlet relative humidity of the air, volume flow rate of the cooling water use, and then inlet water temperature, and etc. So out of the different parameters listed above, the evaporative cooling pad material is an important parameter which the performance of the cooler depends. The selected material should possess a huge water absorbing and holding capacity, increased porosity, huge flow area, reduced weight, higher thermal conductivity, be less costly, non-corrosive, and easily available. So in this experiment, we reduce the water consumption of evaporative cooler by replacing the cooling pad to bamboo. So as a lot of people are interested in using material and products that are renewable, sustainable, and safe for the environment, because they don't harm the environment. However, there has been a lot of research and work done on the use of natural plant fiber. So bamboo in particular have garnered much interest due to their extraordinary feature, which is include but are not limited to sustainability, renewability, and biodegradability. So they have a highly adapted structure as a result of their physical and mechanical qualities and low specific weight. So the performance of the cooling pad is examined by analyzing the data and calculating the temperature under different operating conditions, and the result will be present in chapter 4. Okay, so for the problem statement, sustainable development is widely recognized as a critical idea for the future of humanity. So sustainability requires striking a balance between the short-term economic interests and the long-term development goals concurrently. So when considering the global sustainability of wood resources, it is clear that the supply of industrial wood harvested from natural forests has been declining for many years. This has resulted in a greater awareness of the importance of forest conservation. So as a result, the wood-based industry as well as the plantation in this sector has been significantly impacted. So wherever possible, wood is being primarily replaced with plastic. However, the environmental danger associated with plastic remain a hanging fruit. So, plastic is a useful material due to its many beneficial properties. It is inexpensive to produce, versatile, robust, and multi-purpose. So all of this factors has led to widespread use of plastic. The commodity took this for granted and it discarded while increasing production and consumption. So consumers are not the only one opting for reusable container, and then people can keep adding to the plastic pollution that our water already have. So natural materials such as bamboo may aid in the search for eco-friendly and sustainable solution. So bamboo is a fast-growing, inexpensive to manufacture, widely available, and extremely adaptable. So furthermore, it is a renewable and environmentally favorable resources. As a result, it can be replanted and regrown after harvest. So additionally, if we plant more of it, it can help in cut carbon emission at the same time, because bamboo releases 35% more oxygen because more oxygen than the equal volume of trees. So it is also compostable and biodegradable, unlike plastic. And then next is the objective of the study. And next for this study, there are two objectives that need to be achieved at the end of this research, which is to identify the thickness of bamboo that's suitable to be applied for cooling pad, and to analyze the effect of bamboo cooling pad for direct evaporative cooling. Okay, and as for the scope of study, in general, this study will concentrate on the temperature analysis approach applied by alternative materials such as bamboo, and the experiment will most likely be carried out in one of the laboratories underground level, which may be Mama Primatan Bangunan. So as bamboo has been chosen as the material for the cooling pad, the cooling pads will be provided with three different thickness, which is 100 mm, 200 mm, and 300 mm. Okay, so the temperature will be taken before and after the cooling process, and that will be compared for the goal of determining of the final result. So the existing material will be reviewed step by step to get the temperature before and after using a bamboo as an alternative material for cooling pads. And then the temperature obtained will be compared to other material for cooling pads. So in this experiment, the water usage of an evaporative cooler was lower by substituting the current cooling pad with bamboo pads. So the evaporative cooler usually have a three main part, which is a fan, a pad that holds the liquid water, and a pump that brings the water to the pad. So the fan is used to pull warm water across the pad and then move it around the building being cold. So the pump spray of fresh water into the water carrying medium as needed to keep the system from drying out. So this will let the evaporative cooling unit keep running and work well for a long time. It also can reduce the sensation of suffocation caused by undesired increase in air humidity. Okay, so this is the literature review that have been used in helping doing my current research. So first, Vala. So the title of his research is Comparative Performance Evaluation of Evaporative Cooling Liquor PET Material with Commercial PET. So the material used is salded, aspen, coconut coir, and wood shavings. So so the important observation that I have been found in this research is the average drop in temperature for the different PETs were aspen is 9.75 degree larger than standard at Celsius, and then coconut coil 3.5 Celsius. So, and the lastly is wood shaving pad, which is 3.25 Celsius. So the maximum saturation efficiency obtained for the pad were wood wool 90-20%, and then salded 90.70%, and then coconut coil 67.42%, and then the last one is wood shaving, which is 65.83%. And then the next one is Mali 2011, and the title is Investigating the Performance of Cellulosic Evaporative Cooling Pad Energy Conversion Managed. Okay, so the material used is only cell deck, and the important observation I found is they found that the pressure drop and cooling efficiency increase with the thickness of the pad, and the maximum effectiveness occur at an air velocity of 1.8 for the 5090 cellulose pad with a thickness of 150 mm. So minimum pressure drop occur for the 7090 pad with a thickness of 75 mm at an air velocity of 1.8. So they conclude that the air velocity and pad thickness both play a vital role in the performance. And then for the Wars and Dexmos 2017, the title is Experimental Analysis of Cellulose Cooling Pad Using in Evaporative Cooler. So the material used is aspen, spruce, and cedar. So for the important observation I found is all tested bed indicate that water evaporative rate and pressure drop increase by increasing the air velocity as well as the pad thickness. So the effectiveness of the pad is decreasing. Order was from cedar to aspen, and then the last one is spruce pad. Okay, next one is Slami. So the title is a direct evaporative cooling performance of ambient air using a ceramic wood porous layer. So the material used is a ceramic, and then the important observation I found is they observe a typical decline of 15 Celsius of air temperature by using the pad under the tested condition. So in addition, a better performance could be achieved with a lower air velocity and a high performance of a porous pad. And the next is CON 2011, and the data is environmental investigation of diesel cooler performance using 4 different cooling pad material. So the material used is stainless steel wire mesh, coconut coil, spruce, and wool. And the important observation I found is the order of water consumption by the batch was wood wool is 0.4, and then the coconut coir is 0.134, and then spruce pad is 0.21, and then the last one is a stainless steel wire mesh pad, which is 0.066. So at the same front speed. So the highest performance was observed in wool pad, and the minimum impact made of stainless steel wire mesh. And then as for the Kunhal on 2007, the title is Evaluation of the Sustainability of some local material as a cooling pad. So the material used is a coarse and fine plume stone, volcanic, greenhouse shading nets, and cell deck. Okay, so for the important observation, they found that setup pad exhibited 300 pa pressure drop in all conditions and approximately 80% of cooling efficiency for 150 millimeter pad thickness, which was the best pad. So, but the author concluded that the further investigation were needed to optimize the particle size, the thickness of the pad, and the static pressure. And then next, Dogramachi and Aydin, 2020. So the title is Experimental Study of a Potential of Eucalyptus Fiber for Evaporative Cooling. So the material used is eucalyptus fibers, ceramic pipes, Yellowstone, dry barrel basket, and cypress marble. So the important observation is they found the eucalyptus fiber and ceramic pipe were the extremely appropriate alternative with the cooling effectiveness ranging between 72% until 33%, and then 68% to 26% when the air velocity between 0.1 and then 1.2. And the next is the Liao and Ju 2002. The title is Wind Tunnel Modeling the System Performance of Alternative Evaporative Cooling Pads. And then the material used is coarse and fine fabric PVC sponge meshes. So the important observation found is the cooling efficiency of the coarse fabric PVC varied from 81.75% to 84.48%, and for fine fabric PVC is varied from 76.68% to 91.64%, depending on the varying air velocity, water flow rate, and then the pad thickness. The next is the Martinez from 2018. The title is Experimental Study of the Energy and Energy Performance of a Plastic Mesh Evaporative Pad used in air conditioning application. So the material used is a polyethylene mesh. And then the important observation found is the maximum saturation efficiency of this type of pad was 80.5%, and the maximum pressure drop was less than 70 pascal. So energy efficiency of the evaporative pad varied from 70% to 90% with the decrease in pad thickness. And then the last one is Ahmad, which from 2011. The title is The Performance Evaluation of 3 different types of local evaporative cooling pads in greenhouses in Sudan. So the material used is salted straw and sliced wood. So the important observation found is the study showed that the order of humidification was from a straw pad to salted, and the last one is live wood pads. Also, they found that the straw pad gave the lowest temperature, and the sliced wood pads gave the highest. Okay, that's it for the literature review. And then next we go through the methodology flowchart. And then next is for the testing. So as the water absorbs the air heat, it evaporates and cools the atmosphere. So in direct evaporative cooling, the temperature of a dry bulb is reduced while the temperature of the wet bulbs remain maintained. So an exhaust fan operates by drawing air through a porous water-soaked pad, and air is filtered, cooled, and humidified as it passes through the pad. So a sprinkler with a circulation pump keep the media damp while air travels through the pad. To guarantee that the entire medium is saturated, Often more water is pumped than can evaporated, and excess water will drain back into the water tank. So the evaporating water is replenished by an automatic refilling system. And the effectiveness of a direct cooling is contingent on the pad material. So, and in this case, the main parameter that will vary to compare the performance are the thickness of the cooling pads. As for the sensor, will be put at the entrance to get the reading for primary air, and in front of exhaust fan to get the supply as shown on the above on the past on the above figure on the past slide that I was present before. Okay, so this is the air cooler design, which included a bamboo cooling pad. So this study direct evaporative cooling unit consists mainly an exhaust fan at the unit end and a recirculating pump to provide water to sprinkler and spray on the sides of the pad. So as illustrated in figure below, the air enter the pad horizontally. So the evaporative cooler is made of galvanized steel sheet, and then the head, length and width are 61 centimeter, and 46 centimeter respectively. And the next, as shown below, the packing material consists of a shredded bamboo measuring in 56 centimeter in length and then 56 centimeter in height, and with a different thickness, which is 100 millimeter, 200 millimeter, and 300 millimeter. So the same performance of three thickness will be compared using the same input parameter and material. So water must be continuously circulated over the pad in order to maintain its wetness. Okay, so this is the material used for building an air cooler. First, an exhaust fan. Exhaust fan forces the air it pulls in to move in a straight line along the shaft around which the blades spin. So it functions to bring out the cool air from the cooling pad. And then next is nozzle. The nozzle will be used to sprinkle our water to the cooling pad. Then we have a water pump. Its function is the pumping the water from the tank to the nozzle. As for the water tank, it is to put the water before it's pumped to nozzle using water pump. And lastly, the galvanized steel is used to blow up place to put a direct evaporative cooling system. And then next is for the testing. So as the water absorbs the air heat, it evaporates and cools the atmosphere. So in direct evaporative cooling, the temperature of a dry bulb is reduced while the temperature of the wet bulbs remain maintained. So an exhaust fan operates by drawing air through a porous water-soaked pad, and air is filtered, cooled, and humidified as it passes through the pad. So a sprinkler with a circulation pump keeps the media damp while air travels through the pad. To guarantee that the entire medium is saturated, often more water is pumped than can evaporated, and excess water will drain back into the water tank. So the evaporating water is replenished by an automatic refilling system. And the effectiveness of a direct cooling is contingent on the pad material. So, and in this case, the main parameter that will vary to compare the performance are the thickness of the cooling pads. As for the sensor, will be put at the entrance to get the reading for primary air, and in front of exhaust fan to get the supply as shown on the above on the past slide that I was present before. And the next is for the discussion. Okay, so the experiment is initiated by adding water into a water tank. Then the cooling pad made of bamboo with a 100 millimeter thickness is installed afterward. After the equipment is set up completely, then air flow rate is adjusted and accordingly from the exhaust fan, and then Next, let the experiment run for 15 minutes, and then the variable factor are measured as follows. So the temperature at the entrance, which is primary air, and the exit, which is a supply air. So in the same way, the experiment is repeated again by changing the thickness of the cooling pad to 200 mm and 300 mm respectively. So the saturation efficiency is used in comparison of the cooling pad performance, and the following equation is to determine the saturation efficiency. So the temperature will be measured at 3 times, which is in the morning for the first phase, in the afternoon for the second phase, and in the evening for the third phase. So for the greater efficiency, the cooler will be installed outside of the building. So every hour from 8 a.m. to 6 p.m., the temperature will be recorded. So the data will be collected hourly during the divided phase. Then for the ultimate outcome, the average data from each step will be collected, and the data and formula will be utilized to determine the ultimate efficiency result. And the next is for the expected outcome. So we are expected that at the end of the research, we are able to identify the suitable thickness of a bamboo cooling pad for air cooler. Okay, and this is my references that I use for the this line, and this is my Gantt chart throughout this semester. Thank you for listening.